And I like this application of graphs for several reasons. It's the only math class I've ever taught where I get to talk about both prisms and coloring books. That we have these things called graphs that consist of vertex sets and edge sets. So when you talk about having a graph, G is defined as two things. And I have V, which is the vertex set. And I'm going to be dealing with into simple undirected graphs for this day. So I'm going to have an undirected edge set, which is a set of edges, and each edge is just a subset of V of size 2. This is useful for modeling relationships between things that might exist. For instance, there is the Facebook friends graph. The vertices of the Facebook friends graph are the users of Facebook. And there is an edge between two users if they are friends on Facebook. And this gives us a structure that we can look at. And this is a basic example. Social network analysis is a cool application of graph theory. But if you have a graph that shows sort of compatibility or relationship, you can also use it to look at the opposite relationship. If we have a graph G, there's something called the complement of G. So you denote, there are different things. I like to put a bar over it. Some people use different notation. So this is a new graph, and the vertices of the complement of G are just the original vertices of whatever G was. The edge set of the complement of G is the set of two element subsets such that the vertices are in the vertices of G. And this is not an edge in the original graph. So the vertices are the same original vertex set, and I have an edge here in the complement if this edge is not in the original graph. So you just flip everything in terms of the edge. So for instance, if this were our original graph and we had 1 adjacent to 2, 2 is adjacent to 3, 2 is adjacent to 4, and 3 is adjacent to 4, and this was our original G, what would a diagram for G complement? I'm still going to have the same vertex set. What will the edges of G complement be? Will 1, 2 be an edge of G complement? No. So 1, 2 is not. What about 1, 3? Yes, because it's not an edge here, so it is an edge in the complement. 2 is adjacent to 4, so it's not adjacent in the complement. 1 is adjacent to 4 in the complement because it's not adjacent. 1 is not adjacent to 4 in the original. Are there any other? We already have 1, 2, 3, 4 edges, right? So that's bigger than 3. So here we have 4.